Hey everyone, so this is lesson number 17. Sorry, I'll try to number them. Understanding the definition of the derivative. So we've kind of talked about the derivative, talked about velocity yesterday. I'm lying. Yesterday was 17, today's 18. So now we're going to actually get into the definition. So pause the video and do the do now. This is a practice AP question. All right, so if x minus 3y equals 13 is the equation of a normal line. So remember what a normal line is. It's perpendicular. So I'm going to solve for y. So I have x minus 3y equals 13. So x minus 13 equals 3y. Y is x over 3 minus 13 over 3. So if that is the normal line or the perpendicular line, what's the slope of the tangent line? The slope of the tangent line would be the negative reciprocal, so it would be -3, right? That slope is 1/3. The negative reciprocal of 1/3 is -3. So then what is the derivative at 2? And so it's just the slope, right? Derivative is slope. That's not, oh, there it is. I didn't see the answer. All right, so we've skirted around this, but here's the official definition of the derivative. The derivative of a function is the limit as x approaches 0 of f of x plus h minus f of x all over h. So derivative is just the slope at a point, right? What is the tangent line to the graph at that point? But now we're going to look at the derivative as a function, right? So when I talk about the derivative of, say, x squared, it's not necessarily at a point. We're looking at it in general, like what is the function that is the derivative? So we'll be able to find that using the difference quotient. All right, so to differentiate f of the square root of x and determine the domain of f. So you should be able to do this without my help, even though it's the first, new lesson. So it's the limit as h approaches 0. I'm pretty sure we did this exact problem. X plus h minus square root of x all over h. Whenever you have a square root, what do? You do the reciprocal, the conjugate. Because if we plug 0 in, we get 0 over 0, and that's not allowed. So x plus h plus root x. And we're going to do that on the top and the bottom. So that gives me the limit as h approaches 0, x plus h minus x all over h times x plus h plus root x. All right, so those top. Now the x's cancel, so then we have the limit as h approaches 0 of h over h times those square roots. The h's cancel out, so then we have the limit as h approaches 0 of 1 over. Now on the test, the biggest issue here was kids, you stopped. You forgot to actually plug the 0 in. So when you plug in the 0, you get 1 over square root of x plus the square root of x, which is 1 over 2 root x. So the derivative of the square root of x is 1 over the square root of x. I actually recommend you memorizing this. It's a really good thing to know, that the derivative of a root is 1 over 2 times the root. From yesterday's lesson, what is another name for instantaneous rate of change? That is your velocity. Right? So we can say if a particle is moving along the x-axis and has a position of square root of x, what is the velocity? The velocity is 1 over 2 root x. All right, same idea. Pause the video, try it on your own. All right, this one's kind of annoying. The limit as h approaches 0, because we have it x to the third. So x plus h to the third minus 1 minus f of x all over h. So x plus h to the third. You have to figure out what that is. If you remember, maybe you don't remember. If I use Pascal's triangle, it's 1, 3, 3, 1. So that would be x to the third plus 3x squared h plus 3xh squared plus h to the third. And then we have that minus 1. And then I have to put that in. Minus x cubed plus 1 all over h. So then what cancels? My x cubes cancel and my 1's cancel. Pretty much everything without an h cancels. So then I have the limit as h approaches 0, 3x squared h plus 3xh squared plus h cubed all over h. Now at this point we still get 0 over 0, but what can we do? We can divide. We're going to divide each of these by h. So the limit as h approaches 0. So my first term, 3x squared, that h cancels, plus 3xh plus h squared. Now I can plug the 0 in, and I get 3x squared. So f prime of x is 3x squared, and we are done. All right. The surface area of a balloon is expanding as a function of time according to S of t, right, surface area, is 5t squared. Find the rate of change of the surface area of the balloon with respect to time. What are the units? So again, this is literally just another way, rate of change of the surface area of the balloon with respect to time. So the fact that they're saying that tells me it's a function, right? I'm not just finding the rate of change at 7, right? I'm actually finding a formula. So same idea. We're going to do our limit as h approaches 0, 5 x plus h squared. You could do t if you want, minus 5x squared all over h. So go through, multiply all that out. What do you get? So this is 5 times x squared plus 2xh plus h squared minus 5x squared all over h, the limit. So 5x squared plus 10xh plus 5h squared minus 5x squared all over h. 5x squareds cancel, and then we can divide out the h's. So this gives me the limit as h approaches 0. 10xh divided by x is 10x. And then 5h squared divided by h is 5h. Now we plug in 0. So the 5h goes away, and we are left with 10x. So I would say s prime of t is 10t. I'm going to put the t back in the problem. And then it says, what are the units? So if the surface area is meters squared, what are the units? It's meters squared per second, right? Meters squared per second. The reason is because remember this is just slope, right? The top, that's your f of b minus f of a, or your y2 minus y1. So the numerator is your meters cubed. The denominator, or your x, is being subtracted. That's over t. Why did I put m cubed? It's m squared. So m squared over t. So it's m squared over seconds. All right. Determine if f prime of 1 exists. So what do you think we need to do here? We're going to do the derivative at 1 of the top piece and the bottom piece. Now, since they're giving me the 1, if you want to make it easier and do the limit of like f of x minus f of 1 over x minus 1, that's probably a little easier. So why don't we try that instead? So the limit as x approaches 1. So I'm going to do I'm going to start with the top, negative 2x squared plus 4 minus, let's see, if we plug 1, this is really 1 from the left, right? If we plug in 1, we get 2 all over x minus 1. And then we're going to do the limit as x approaches 1 from the right. So now this is the bottom, x squared plus 1 minus 2 all over x minus 1. So let's see if we get the same answer. So the limit, x approaches 1 from the left, negative 2x squared plus 2. All right, so I have to factor out that 2, negative 2, x squared minus 1. So that's negative 2, x plus 1, x minus 1, all over x minus 1. And then we can plug in 1 and we get negative 4. Let's see what we get on this other one. So the top, x approaches 1 from the right, we get x squared minus 1 over x minus 1, x plus 1, x minus 1. So this time we get 2. So the answers are different. So no, it does not exist. Right? The limit does not exist. Or the derivative is not. The derivative does not exist at 1. So no. F prime of 1 does not exist because the slope from the left and the slope from the right are not equal. All right. If a function f has a derivative at a number c, then it is continuous. So this is really important. Remember on the test we did our is it continuous, IVT. So sometimes they won't tell you it's continuous, but they'll tell you it has a derivative. So if it's differentiable, then it's automatically continuous, right? If a function is discontinuous, then it has no derivative. So yeah, if they tell you it has a derivative if it's differentiable, that's giving you enough information to say, okay, it's also continuous, so I can use the IVT or some other theorem that I want to use. Okay, so that's the lesson. Now some practice problems. So go through, figure these out, pause the video. All right, so we have, which of the following is true? So what do we have to do with that one? If we cancel, factor the top, x plus 5, x minus 5, over x minus 5, those cancel. So if we plug in 5, what do we get? We get 10. So that what does that tell you about this problem? It is not continuous. The limit exists, but it is not continuous. It is not differentiable. Because remember, this thing looks like this. It's a line, x plus 5. This point is 10. This is the y value 10. But it has a closed circle down here at 5. So the limit exists, but the function value isn't the same, so it's not continuous. If it's not continuous, it's not differentiable. Let's see. So now this is, what is this asking about? This is the definition of the derivative. So it's asking about derivative, which is just slope. Slope at x equals what? They're asking me about 3. So all this is saying is what's the slope at 3? So if I go to 3, I have a line segment. What's the slope of that line? So let's see, it goes up 4 over 6. So negative 4 over 6, because it's going down. Negative 2/3 is the answer. All right. Suppose f is a function that is differentiable in the open interval. F of 0 is 3, f of 2 is negative 3, and f of 7 is 3. Which of the following must be true? All right, so I'm going to draw myself a picture. Let's see, 2, so positives mostly. 0 is 3. 2 is negative 3. And 7 is 3. Now, if it's differentiable, we know it's continuous. So let's see, what has to be true? F has to have 2 zeros. That's true because it has to somehow get down here, right? Now, it could have more than 2, but it has to have at least 2 because it's continuous. It's continuous from -1 to 7. It's telling me it's differentiable from -2 to 8, so that is also true. And for 0 to 7, we have to hit -2 at some point. That is also true. Again, because it's differentiable, it's continuous. So we're going to hit, from 0 to 7. Just checking. Yep, that does work. So 1, 2, and 3. At x equals 2, the function is both continuous and differentiable, continuous but not differentiable, differentiable but not continuous, neither continuous nor differentiable. All right, one of these we can just cross off right away, right? There's no such thing as being differentiable but not continuous. That's impossible. If it's differentiable, it's automatically continuous. All right, so let's check if it's continuous. So the limit from the left, does the limit from the left equal the limit from the right? So the limit as x approaches 2 from the left, so that's the top function, is 9. And then the limit as x approaches 2 from the right of f of x is 3 times 4 minus 3 is 9. So that's correct. So it is continuous. So it's not D. Now the question is it differentiable? What's the slope? So this is a line, right? So we can just kind of cheat there. The slope of the top is 4, right? So if we did f prime of x, the top is going to be 4. The question is, what's the slope of the bottom at 2? So now a little bit more work. The limit as, we can do x approaches 2, the easy version, right? 3x squared minus 3 minus 9 all over x minus 9. And we are going to get 12. This is not going to work. X minus 9, that's wrong. X minus 3. X minus 2. Wow. My brain is working real good here, guys. Because that's 3x squared minus 12. X squared minus 4. So we get 3x plus 2, x minus 2 all over x minus 2. The limit as x approaches 2. Those cancel. Plug in. We get 12. So it is not differentiable, so the answer is B. All right, and there is your homework. Have a fabulous day, guys and ladies.